Hello everyone, I think it's 11:15 and we can start this session. And I'm Kangyu and I'm the session chair for this room. And welcome to the session, Novel Approaches to VR and Games, Neurodiversity, Tangibles, Wellbeing, and more. And today we will have 7 papers will be presented in this room. And after each presentation, if you have any questions, you can just use the microphone in the middle, just use it. And also you can raise your hand and our SV will pass the microphone to you. And now let's welcome our first presenter and Xiwen Yao. Yeah. And she will give a presentation about gesture rope 3D virtual reality prop generation with code speech gestures. Okay.
Good morning, everyone. I'm Xiwen from Tsinghua University, and now I'm a senior undergraduate student, and now I'm interested in human-AI interaction and the development of AI creative system, and I'm also interested in plotting border areas in HCI. Today, I'm excited here to show our work GestuProp, a VR system that explores how people can create 3D objects naturally through gesture and speech. First, for our inspiration, in a lot of fantasy and sci-fi movies, we often see the scenes that the people can pose their gesture and imagine what they want. The object will directly show in their hand. Actually, this way of expression ideas also exists in our daily work. For example, if I want to express what I saw just now, I would say, on my way to the center hall, I saw a little green bird on the road. We can find that we often naturally measure the word with our bodies before we measure it with tools. And when we describe things, we rarely rely on words alone. This is what we call code speech gestures. Our hands and language naturally work together and is one of the most intuitive ways we express ideas. Today, speech and gestures are already being widely used in many interactive systems, such as selecting, moving, or sliding, and etc. However, the exciting applications focus on manipulating objects that already exist. So, what if speech and gesture could be used to create, but not just to control? With the rapid development of Gen AI, it's a good timing to dive into this question. To explore this question, we choose virtual reality as our research medium and context, because VR provides an ideal environment where object creation and body interaction naturally come together. So this leads to our question. In VR, how can we use AI enabling people to create objects they want to create both naturally and intuitively? More specifically, how people use gesture and speech together to describe a new object. To answer this, we conduct a formative study with 30 participants. We ask them to create objects using gesture and spoken languages without any predefined interface or tools. From over 240 gesture speech samples, we identified 4 key express dimensions in how people naturally express object creation. First, we found that users consistently rely on a small set of gestures to express spatial structure across different objects. In particular, there are 4 main types: pinch, grasp, hold, and another sketching model. The first 3 are already widely recognized in previous gesture research. Sketching gestures emerged in our study as a distinct and important category used when users want to outline a specific shape directly in space. We also observed a body-centered pattern. Users naturally use their body as a reference. Like large extended gestures often indicated larger structures. For example, as shown here in the right, when users say, I want a magic wand, the left gesture is interpreted as a large step, where if the smaller, closer gesture, the user maybe wants a Harry Potter style wand. While gesture expresses spatial structure, speech provides semantic information. We found that users' language is highly consistent and typically included 3 components. Categorical semantics shows what the object is. Qualitative modifiers express what it looks like. And the detected depression show how it relates to the gesture together. For example, in the sentence, please give me a blue plate this big. So the plate defines the object category. Blue specifies the appearance, and this big is a detected expression that directly refers to the gesture together. When users say phrases like this or that, they are highlighting a specific gesture state. Interestingly, users tend to keep their language simple and underspecified, rely on gestures to carry most of the spatial meaning. Finally, we found that object creation is not purely geometric. Users' ideas are often influenced by the physical environment, the text narrative, and their experimental experience. The factors shape how users describe objects in terms of form, material, and style. This suggests that object creation is also situated and experimental. Based on these findings, we summarize 3 core design requirements: flexible input modality, generative mapping strategy, and interaction experience. So based on this insight, we developed GestuProp, a VR system for 3D prop generation using code speech gestures. As shown in our system pipeline, the process consists of 4 stages, including user gesture and speech naturally input, feature mapping, and lightweight proxy model, and the final high-quality 3D object generation. Before generating the final model, we introduce a proxy model as an intermediate step. We use different levels to organize the proxy model library. During generation, the system chooses the best match. This reduces waiting time for users, will also provide essential potential and structural information for later high-quality model generation. For example, if a user says, give me a gun, where making 2-hand grasp gesture, the system first refers the object category, then extracts the gesture features to determine spatial parameters. Based on this information, it immediately generates proxy model and places it in user's hand. Then the final detailed 3D object is generated and replaced. Importantly, the interaction requires almost no learning. Users simply use their body as they have already do in everyday communication. In sketch mode, users can also draw an object outline directly in the air, allowing them to create more customized and free-form shapes. We further conduct a user study with 14 participants, successfully generating a wide range of results, confirming the system usability, and revealing how object categories influence gesture use and interaction. Beyond usability, our study also shows that code-speech gesture interaction creates a strong sense of embodiment. Users reported that generating objects felt intuitive, playful, and even magical, as if they were smoothing objects directly into the existence. Based on these findings, we're highlighting some design implications for further research, linked to improve spatial feedback and visualization, enhance semantic understanding of objects, supporting more flexible multimodal interaction such as stage creation, and further explore how environmental context influence user expression and experience. In conclusion, GestuProp demonstrates that by combining gesture and speech, we can move VR object creation from command-based interaction toward embodied expression, bringing digital creation closer to the way humans naturally imagine and communicate. Thank you for your listening.
Yeah, okay, thanks for the presentation. And if you have any questions, you can just use the mic or you can raise your hand. Okay, this one. Oh.
Yeah, this is Zi from UIUC. I'm wondering how you align the generative 3 model to the proxy in a really rough shape.
Okay. For user, for example, user puts the gesture they want again. Our system will modify the features, the hands distance, and the data will put in the Unity, and where the proxy model will first fit the the hand shape, and then the 3D final generating model will shoot in the hand.
So my question is, how 3D model align with the proxy you align with the user's hand?
Yes, the proxy model will fix the size of in the hand, and the final model will directly shoot for the size of the proxy model.
Okay, thank you.
Thanks.
Okay, and thanks for the presentation. And now let's get into the next one. Let's welcome Hayato Saiki to give us a presentation. Bridge Borderless Reconfiguration for inclusive and diverse gameplay experience via embodiment transformation. And yeah, as congratulations to him, this paper get a Best Paper Award. Yeah, and good. Okay, let's start.
Okay, so thank you for introduction. My name is Hayato Saiki, a PhD candidate at the University of Tsukuba. So today I will present our work on bridging the information gap between the parasports and the non-disabled sports. So today there are many videos for sports training, such as broadcasts and instruction. However, most of these resources focus on the non-disabled sports. So for the parasports, such as wheelchair basketball, still remains limited. So as a result, although parasports athletes have different embodiments, they often rely on the non-disabled sports videos for training. Because this type of learning depends heavily on the personal interpretation, it can be difficult to accurately understand and apply the training. Therefore, we investigate the challenges that parasports athletes feel when learning from non-disabled sports videos. To explore these challenges, we interviewed wheelchair basketball athletes using stand-up basketball videos as material. The participants include 8 national team players and 2 national team coaches. After the interview, we identified 3 key challenges. The first one is adapting movements from stand-up basketball to wheelchair basketball. For example, some movements are difficult to perform in wheelchair basketball, so this creates a significant cognitive burden, making it harder for players to focus on the tactics. The second one is interpreting body orientation from stand-up basketball in a wheelchair context. In a stand-up basketball, body orientation does not always match the movement direction, but in the wheelchair basketball, orientation is closely tied to movement. This makes it difficult for players to interpret directional cues from the video. The third challenge is adapting tactics to different impairment classification in wheelchair basketball. Because players have different physical capabilities, the same tactic needs to be executed differently. This makes it difficult to achieve team coordination. So given these challenges, I will introduce 2 related works on existing technologies. The first, we introduce the embodied tentacle, which maps human finger movements to a non-human body, such as a tentacle. The second, I brought this system as the visual data to basketball videos, and this helps people understand the game. So these studies demonstrate the potential of embodiment transformation and the visualization technique for enhancing user experience. However, existing research on embodiment transformation has mainly focused on the interaction between the humans and the non-human bodies. In addition, in the domain of the tactical running, little attention has been paid to how knowledge can be transferred across different embodiments. To this end, we propose Bleach. Bleach automatically transforms the non-disabled sports videos into wheelchair-based simulation. This reduces the cognitive effort required to interpret the movement, allowing para-athletes to focus on the tactics. It can be applied to diverse video sources, acting as a bridge that reduces the information gap between non-disabled and para-athletes. So next, I will describe how our system is implemented. So here is an overview of the Bleach pipeline. So first, non-disabled sports footage is taken as inputs. Then system tracks the player and the ball while detecting the court. So it uses the mix sort for stable player tracking, and the YOLO and the sound 2 for accurate ball tracking and the courted key point detection. By applying homography transformation to the obtained data, we map the camera footage onto the court coordinate system and reconstruct the game. The next, based on the tracked player IDs, we extract the 3D mesh data for each player. So from the mesh data, we extract the orientation of the head, trunk, and the movement direction, and apply them to the corresponding head, trunk, and wheelchair base in the player model. In this mapping process, the range of motion of the trunk and the head is constrained according to the level of impairment. This enables the representation of the functional differences across the players. So finally, by combining the game reconstruction and the embodiment mapping, we generalize the 3-dimensional wheelchair basketball simulation. So in the first user study, we compared videos with embodiment mapping to those without the mapping in order to examine perceived motion realism and whether participants could visually judge the functional differences among the offensive players. The study involved 20 participants, including 10 national wheelchair basketball team players and the 10 non-elite players. As a result, the mapped condition was rated significantly higher in terms of their perceived naturalness. And the participants described the non-mapped condition as robotic, whereas the mapped condition was perceived as much closer to real gameplay. Regarding the recognition of impairment levels, under the mapped condition, participants were able to classify functional levels with high accuracy. This result suggests the embodiment-aware mapping facilitates the perception of functional differences. So in the second study, we conducted a comparative experiment using standard basketball videos and bleach videos. We evaluated the self-efficacy and other subjective measures, such as the vividness of imagery. Self-efficacy was assessed by asking participants whether they felt capable of executing similar tactics after viewing each conditions. So self-efficacy was significantly higher for the transformed videos, particularly for more complex tactics. This suggests bleach not only improved the understanding, but also enabled athletes to feel capable of executing challenging plays. In the subjective evaluations, bleach transformed videos were rated significantly higher across all items. At the same time, some participants noticed the ambiguity of standard basketball videos can inspire new ideas. Overall, the results suggest that while bleach enhanced the interpretability, standard basketball video provide complementary value for idea generation. So in the study 1, many participants reported that the transformed video made functional laws easier to recognize and appeared more natural overall. This suggests that aligning body cues reduces the cognitive effort required to reinterpret the movements. In study 2, participants reported the positive reactions, such as I could do this with some adjustments, and I want to try it myself. This indicates that aligning embodiments not only improves the understanding, but also increases the sense of actionability. The participants also noticed the resources based on the different embodiments are variable for idea expansion. So different embodiments provide a new perspective, and the bleach enable actionable understanding. This approach is not limited to the parasports, but can also be applied to areas such as education for the children and medical training. And more importantly, this research raises the broader question, whose body serves as a reference for knowledge. It suggests that not only non-disabled bodies, but also diverse embodied experiences can serve as valuable learning resources for others. Okay, before I finish, I'd like to mention that I'm on the job market and looking for the next position, and postdoctoral opportunities. Thank you for listening.
Yeah, thanks for your presentation. And now, anyone have questions? Okay. Yeah, there is one.
Hi, thank you for your presentation. I'm Roshan from Rochester Institute of Technology. Yeah, it's really interesting to see how that transformation works. I'm wondering, have you thought about, because some, like when you look at the different sports, the rules change as you look at, for instance, in wheelchair tennis, you allow 2 bounces compared to the regular events where they allow only 1 bounce to play the event. So have you considered those kinds of aspects, or did you find any feedback on those kinds of aspects when you interviewed your participants? Yeah. Thank you.
Thank you for the question. So you mean the participants mentioned the quality of the, how can I say, transformation?
Not on the transformation, but sometimes like the sports, when you consider like wheelchair sports, sometimes the rules change. So when you convert directly from like the stand-up player to the wheelchair player, like maybe some of the tactics need to be adapted to change to the change of the rules as well. So I was wondering about like if you found any feedback on that. Yeah.
Yes, thank you for the question. So yeah, participants also mentioned the same thing, like this cannot be directly applied to the actual wheelchair plays, but still they feel it's useful because usually they utilize the stand-up basketball videos like as a reference for new tactics exploration. So people usually do in the brain, just image, but people can see actual like movement. So it's still useful for those things. Yeah. Thank you for the question.
Okay, more questions? Okay, if no, we can get into the next presentation. Okay, thank you.
Thanks so much.
And let's welcome the next presenter, Anisha, to give us a presentation, Playing for Wellness, a diary study of video game usage and adolescent well-being.
I've done a walk of shame now. Yeah, it's always good when you start on an embarrassing note, right? One sec. That's put me off a little bit. I'm taking time to recalibrate. Welcome to Kai, day 4. Okay, yeah, that worked. Welcome everyone to our talk. I'm not sure we're in the right session, so just sort of go with the flow. Playing for Wellness, that's the name of our paper, and it's a diary study of video game usage and adolescent well-being. This was a really fun project. It started off with a really small pot of money and a group of people who really like each other, I think, so far. Maybe not anymore. Andrea was a MSc student who joined the project later, and he did a lot of the empirical work. Kai plushies are out. I created a Funko Pop, if anybody is interested. He couldn't be here. That's on the screen. That's Andrea. And my other co-authors, Wen and Izzy, are sitting right there. So the motivations for doing this piece of work were that adolescence or teenhood is a period of profound emotional flux. Yet teens rarely seek formal support. And 89% of UK teens already play video games. This is because this study was done in a UK context. Weekly, that's the figure. Games are deeply embedded in their lives, in their social lives, in their personal lives. And also such research is underrepresented in HCI. It is more difficult to do research with teens for pragmatic reasons, and ethical reasons, and other reasons. So these were some of the motivations. But also we were seeing a rise of video games being played for more reasons during COVID, a lot more uptake, and changes in the way people were using these as tools. So we wanted to study what was going on. And the question we were asking was, how do teens naturally use mainstream video games to regulate emotions? And how do these practices intersect with their social relationships and daily emotional experiences? This slideshow obviously has a mind of its own. Specifically, we were investigating how adolescents select and engage with games in response to their own emotional needs during the day, how social interactions in and around gaming supported and challenged emotion regulation strategies, and also the mechanisms through which gameplay was eliciting responses. So the methods that we used were like a 2-week diary study. I told you it was a fun project, so we created a box of things. We gave them a watch, we gave them a phone with an app on it, we gave them some clay materials, we gave them post-it notes and pens and all of that, and we were curious to see what they would use. We used, they were onboarding interviews to learn more about their gaming practices, but then also follow-on interviews, semi-structured interviews. And the choice of games was not restricted. They could play whatever they wanted. We were just interested to see what they were doing and why. There were 11 adolescents who took part in the game, in the study, between the ages of 14 to 17, and they were part of 2 secondary schools in London. And it was a very mixed group, 5 girls and 6 boys, and yeah, they all played for more than 5 hours per week. And here on the right, you see the actual diary structure that we had, and we looked at what games they were playing and things like the start time, the end time, to see how long each session lasted. There were some prompts, but also there was space for them to free write or use their little stickers and emojis and things like that. We also have a section for heart rate there. If you can see, that was not to see, that was not an absolute measure. It was to see how they would interpret their own heart rate when they were playing the game. And that was interesting for us. As you can see, it was very difficult to decipher all of them. The handwriting, I think it took us lots of group sessions to really understand what was being said. And it was not just the semantics of the writing, the legibility of it. It is also the kinds of things that they say and the way they say it is very different to the way well, at least I speak, I'm very old. So hence I have a very young team working with me. We also have lots of ways of expressing. So they were writing and they were doing, but they were also like drawing on post-it notes. They had post-its full of strategy scribbles before they went into a game, afterwards, analyzing, downloading. So it was quite very interesting. So what did we find? I'm going to whiz through some of these. So there was a strategic mood-aware game selection. Is it an exam day? Have I had a rough day at school? Did I fall out with my friends? Did I have a really good day? All of that factored into how they chose the game. And they did have a reason for choosing those games. So like this one says, even before replaying this game, I can feel how emotionally intense I'm going to be once I press start a new game, and the person's really looking forward to it. And they really look forward to this. And this kind of shows that they were thinking through these affective niches, the idea that emotions aren't just things that happen inside your head. You can structure your environment and other things, and these games were part of these affective niches that they were creating and curating as they went along. So they also, in terms of choosing a game, it varied, whether it was holiday or weekend or after a long day at work and at school. So for example, here it says on holidays and on weekends, it tends to be more competitive. When it's after school, I just want to play something that's going to relax me, because obviously I woke up that early. Or during the week, if you want to play a game, we'll just play something just regular. And then during weekends, after we have met up, we usually play like a more social game. So it also varied depending on whether they had just met their friends or whether they wanted to hang out with their friends and they'd not met them for a while. All of that changed how they picked a game. It was also a refuge. So for example, this person said, after 50 minutes, I took off my headphones and took my breath as if re-entering the real world. And also finding space for themselves. Gaming let me sit down and work on something for myself. And these things can really be misunderstood, because if I see my child gaming during exam season, I'm just like, why aren't you working on your maths? Like, what's going on? But these are sorts of ways of resetting and re-regulating that should be allowed. There were ways of being flexible and adaptive. So they would change games or change strategies within games. Like this one said, I was a little tense and decided to play DC Lego Supervillains because I thought it would calm me down. Well, how wrong I was. And then this one, I tried again and again, but every time they won, so I got really frustrated. So I decided after a while to go to a herbology class instead. And it was easy and it calmed me down. And there were times when they would just lurk and follow their friends around in a multiplayer setting because they couldn't be bothered to do anything. At other points, that frustrated them. Then this one talked about achievement and positive affect. And here is the heart rate and how we were using it. Just like, I'm so happy my heart rate is currently 97, started at 78. I took photos because I was able to achieve something I did not think I could, which made me determined to do better. And took a picture. That's the picture that they took in Overwatch. There was also mixed affect. Like this one, it's like, I'm happy even though I rage quit every single game. So it's like, if you kind of think that means that they were enraged, they were not. They were actually, it was a release in a way. And so there are these mixed, nuanced ways of looking at these things. So there's this beneficial negative affect, which can also have persistence and growth. The diary also supported reflection and reappraisal. I think I did make me more reflective and observant. I was stepping back and looking at things, or playing the game made me more furious than I was before. However, realistically, it's my fault. So they were writing the diary and they were introspecting. And they were also using the diary to say me before the game, me after the game. There's a bit of fun going on. There was co-regulation and co-connection, so there was a social aspect of things. So there's no need to be like nervous about conversation because you can make conversation about the game, so it's like scaffolding in terms of social stuff. And also like during lockdown, a lot of them were using this to reconnect with people they couldn't meet. So we'd play Minecraft, and normally I'm quite happy afterwards because I feel like we've connected again. So it's a way of getting a connection, but it's low stakes. Again, there's emotional strain and social risk though. Well, this one got really angry. Whilst we played longer, my friends would not take the game seriously, which was ruining it. Eventually, I grew sick of it and left the game. And the other one obviously loved it because it gets competitive, but I usually win, which frustrates me because they want to prove they're better than me. So there's all of this complicated stuff going on. But there's also sort of nostalgia and socially embedded things like I associate Minecraft with a bad friend, so I feel bad, I'm trying to unassociate, and that gets memories back. Or I kind of miss the days I used to play with these two games, and this one was a really emotional interview as well because the person had moved countries and it was during lockdown and had lost connection but not made new connections, and it was really intense for them. So what does all of that mean? So our implications are for theory, gaming can serve as an effective niche, not just a distraction. People are creating and curating these niches, but that needs more work to unpack what's going on. Emotion regulation is relational, not purely individual, and a lot of the models talk about it as individual reappraisals and things like that, but there is a lot more work that can be done around social things, and especially digital tools that are reframing this in ways. Mixed states and instrumental use of negative emotions, it's not straightforward to say if somebody looked angry, they actually were. And we also thought about adaptive versus avoidance gaming. From the outside, you don't really know whether what's going on is adaptive or avoidance, because when you talk to them, they have a nuanced way of looking at it. There's low stakes in-game transitions for frustrated players, so if they find one mechanism like sort of complicated, they go and do something else, even within the game. So it's not like you need a new app for it. They were able to do this. There were subtle reflective prompts without breaking immersion. And of course, there are methods. We're not proposing that what we've done is new and revolutionary. Well, maybe we have. But the diary is something that's been used with teens before. I think how we've used it in a more creative way could be done more, giving them tools that, because they're people who are visual, people who like stickers, who are not very communicative. There are lots of ways of doing these studies, and we can be more creative about it. And more open-ended to see what meanings people are making from the tools that they're using. Yeah, and the diaries and interviews gave us complementary richness. I have some closing thoughts. Games can be looked at as emotional rehearsals. Teens aren't just regulating emotions. They're building capacity. So these rage quit cycles, frustrations, tolerance, and so on. There's like muscle memory, and this repeated exposure can help with that. Maybe we can double down on that rather than avoiding it. The diary was an intervention, could be seen as an intervention, not just as a method. So were they actually reflecting on the game, or were they reflecting on the reflections from having done the diary study? Were they just in a more reflective mode? That is something that to be unpacked, but I don't think that takes away from the fact that it was also a good method to see what was going on. Nostalgia could be seen as emotional labor. P10 consciously tried to detach Minecraft from a lost friendship, for example. This meaning reconstruction was like something like therapeutic framing done intuitively. Social or solo switching was a form of interoception. Moving between these isn't casual. They were thinking about their internal states and choosing to do other things based on how they were feeling. Sometimes it was the trust, not the game itself. They were getting annoyed with their friends and so on. They were changing things. And so we say digital play can be a primary site of this kind of emotional development, not just a distraction from it. So what are some of our takeaways? It's already being used strategically. Let's look at it more. Commercial video games are effective tools. Emotion regulation can be fundamentally seen as social. Multimodal diary methods are nuanced. And I've already talked to you about some of the things that we can look at, but make things more intentional, maybe in certain ways if we want to look at how this unfolds in daily life. And that's us, the papers there. And thank you to all my co-authors for all the excellent work and the great laughs we've had along the way reading these diaries. Thank you.
Yeah, thanks for your presentation. And now, here's a question.
Thank you so much for the presentation. I'm just trying to be a bit of a devil's advocate here. Really sorry if I'm going to put you on the spot, but in one of your findings, you said that you found that video games are adaptive tools for emotion regulations. And could video games actually also be maladaptive tools for emotions?
Absolutely.
Because they're using it as like emotional catharsis, or when they're facing like procrastination, they use video games for this avoidance of negative emotions that come. Thank you.
Absolutely. So I don't say video games are necessarily adaptive. I think that they're using them as adaptive strategies, but also avoidant strategies. And from the outside, looking at it, it's not easy to tell them apart. And I do think there are regulation strategies that are still required to I'm going to make this personal. I have a teen, and there are times when, after a while, if she's been there for 3 hours or whatever, I would want to tell her that, and now it's getting a bit too much, even if it's lots of adaptation happening, you maybe want to step out of it. And maybe there are ways that we need to, work with them, because it can be an escapist way of dealing with things. So absolutely it can be maladaptive. But I think I'm trying to do the exact opposite, because a lot of us are talking about them more as maladaptive, but there is a lot more going on there than just, I don't want to talk to you, so I'm going to put on my headphones, and we should look at both sides, and we should see how we can regulate it. But also, we should not think that they don't know what's going on. So having teen voice, be actively involved in how this is shaped, whether adaptive or maladaptive, asking them what's going on, or why they're doing a certain thing, might also be maybe something where there's time for a dialogue rather than this person is addicted. So we should start thinking about it in a more nuanced way. But that's an excellent question. Thank you.
Okay. And considering the time constraints, we have to move to the
Absolutely.
another one. Yeah.
Thank you.
If you have more questions, you can discuss after the session. Okay. Let's welcome next presenter, Philip, to give us a presentation. More aware and more curious to understand emotionally challenging experience in psychological horror games.
Hello, my name is Philippe Tutme, and I'm here to talk about horror games. So, how do you feel about horror games? Do you have nightmares? Do you feel it's scary sometimes? Are you ready to get scared for this presentation? Because, if the computer works with me, because I'm not, because it's going to be a fun edition. You're going to see the fun aspects of psychological horror games. I made some cool drawings I'm going to show you. And drawings, I want to give a special thanks to Flork of Cows. They gave me their permission to redraw this cute image in this art style, so thank you. So let's begin our presentation with Act 1, which is the related work. And is mental health representation in games. And hey, surprise, it's negative, because most of representations of mental illnesses reinforce harmful stereotypes and often frame them as a primary explanation for violent behavior. For instance, schizophrenia was the most frequently depicted disorder and was often portrayed negatively. And we know that previous studies have explored how agency, narrative, and empathy can lead players to reflect on real-world issues, such as mental health. But how can psychological horror explore it, and what is psychological horror? So, psychological horror is it's a subgenre of horror that explores the character's deeper spheres, intrusive thoughts, and internal conflicts. And these narratives often center of character spheres and anxieties. But, the relationship is not that well because, psychological horror games are also the game that stigmatize a lot because they are not portrayed accurately. But there has been some recent research that has shown that engagement with psychological horror can promote emotional regulation and resilience, and can even help to destigmatize mental health. So, what is emotionally challenging experience? So, it's a concept that basically, instead of being a challenge that you confront with gameplay, but usually it's by resolving the tension in the narrative by identifying with the characters and by resolving ambiguities. So discord and reflection through emotional challenges can lead to reflection, but can they make players reflect on mental health? So we grabbed our related work, started to cooking some research questions, and we came up with these two. So, how do emotionally challenging experience in psychological horror games and as players emotionally connected to the characters, and how can psychological horror games support players' reflection and broaden their perspectives on mental health? So we begin our Act 2 with our study design, and we decided to analyze players that played recent psychological horror games released in the last 3 years, and that were both AAA games, Alan Wake 2 and Senua Saga Hellblade 2. So we recruited 16 participants. So we interviewed 8 players that played Alan Wake 2 and 8 players that played Hellblade 2. And we started to interview them, started with general questions like, hey, what was your main reason to play these kind of games? Then we both watched an emotionally challenging cutscene in the middle of the interview. So in Alan Wake 2, you have Alice Wake giving an heartbreaking speech that showcases her mental health condition, the depression. And in Hellblade 2, we show a cutscene when you play as Senua, the main character, and hear multiple voices in your head and see audio-visual distortion, mimicking her psychosis condition. Then we resumed our interview and asked more specific questions. So, hey, these horror elements help you to connect to the characters. Then we finished with the Toronto Empathy Questionnaire to measure their empathy levels. And in this, only one participant was excluded because they have a low empathy score. And we did very briefly a thematic analysis. So we started with data familiarization. We generated our initial codes. We searched for some themes. We reviewed our themes. We defined and named them. And then we report this in the current story. And what is our story? It's our 4 main themes. We're going to talk about 3 for the sake of time. And now we bring to the final act of our presentation, which is the results. So the first one is psychological horror, tension, and fear enhance immersion. Fear and discomfort play a significant role in immersing players in both games' worlds. So across all 15 participants, feelings of tension, anxiety, fear, and discomfort and unease were frequently described as central to their engagement within the psychological horror game. They also mentioned there is a cathartic feeling because they felt really tense while playing these games, and there was a sense of release. You probably might be asking, hey, what is the cathartic feeling in horror games? Don't worry, because I make drawings to explain. So this is me, for instance, playing the game. Now I get really scared, really shocked. Sometimes I cry, I get sad, and then at the end, hey, I'm good again, because I relieve that tension. So for next two themes, we'll introduce emotional empathy and cognitive empathy. So what is emotional empathy? So emotional empathy is the ability to share another person's or character's emotions, and cognitive empathy is the ability to understand the perspective of others. And why empathy is very cool? Because I like being empathetic, I like to play games, I like to feel scared. This is me playing Detroit, and as you can see, yeah, I'm kind of sad. So, horror elements in players' agency foster emotional empathy. So across both games, players mentioned that these horror elements strengthen their connection to the game's characters. They mentioned that fear and discomfort heighten this connection with the players and the characters. For instance, player 8 mentioned that they felt every range of emotion while playing Alan Wake 2. In Hellblade 2, the same. Participant number 9 mentioned that the horror elements made them better understand the seriousness of psychosis. And let us move to the next theme, which is like the cognitive empathy. So this was a major difference across both games. So mental health reflection does not guarantee perspective change. Cognitive empathy, for instance, like for Alan Wake 2, our first game, participants report that the game did not change their perspective on mental health. Although like several participants reported or reflected on the portrayal of depression and suicide, for instance, they emphasize that this reflection did not lead to new understandings. Like some participants, participant number 1, they say that they could not relate to the characters because the characters were mentally ill because of supernatural, and that's not really realistic. So that was one of the explanations. Another is like anxiety depression is far more common than psychosis. I mean, if you are a PhD student, you probably have anxiety depression and sometimes, so so Hellblade 2 was a major difference because players wanted to know more. So after they played the game, some of them actually went to read more about the subject. They were more curious. They were made more aware and curious to understand. And this was the title of our paper. So how is mental illness explained in Alan Wake 2? I do some drawings to explain, of course. So you are normal, you are a normal character. There was this supernatural entity that comes into you, and now you have mental illnesses. Hey. And in Hellblade 2 is very different because Senua, the character, she is not supernatural. She's just a woman that lives with psychosis and is far more realistic. And in the game, you can play as Senua and hear how she experiences psychosis. But in Alan Wake 2, there is no gameplay mechanics to showcase her mental health conditions. So let's address the responsible and ethical considerations for future psychological horror games. So, our games can be a lot of fun, and they can also even help players to develop empathy. However, it is also important to recognize that these games can also be distressing for some players. Like it can raise your heart rate, get easily scared, be tension. So what can we do? So one of the options is include the content warning at the beginning of the game. Some games already do this. They warn the players. This says there's some portrayal of mental illnesses, and also we should provide with mental health resources. For instance, Hellblade 2 does this. So what is the future consideration for mental health in psychological horror games? So we suggest that mental health reflection should be true. One of the ways should be true of gameplay, agency, and emotional challenges. And the gameplay should include specific mechanics that showcase the grounded perspective of mental illnesses to better understand the protagonist's perspective and foster cognitive empathy towards them, because this is our main difference between Alan Wake 2 and Hellblade 2. So I'm taking these findings of my rated work and my previous papers. I'm making my own game, and hopefully I will be the next guys to present it. I recently received funding, so if you like to know more or ask some questions, please, now it's the time. Thank you for your time.
Yeah, thanks for your presentation. And now, question part.
Hello, Burkhard Wunsch, University of Auckland, New Zealand. Thank you very much for the talk. Really, really interesting. And I love those cute characters.
Thank you.
Well done. I've got a question. Have you looked at cultural differences? So I'm personally not a fan of horror movies or horror games. But I did watch a few, in particular when I was in Korea and Japan. It's part of the culture in Korea. It was even promoted by the Korean Cultural Center. But the movies are very different from, say, American horror movies. I'm not sure whether the same applies for games. But also when talking to people, they watch horror movies for different reasons. So I wonder, is the same true for games? If you looked, say, Asian versus Western culture?
Yeah, definitely. Thank you so much for your question, and also agree there is a major difference between like Western horror and Eastern horror. Like for instance, like for ethical reasons from my university, I couldn't showcase you what was our characters or players demographic. But yeah, there is a major difference. For instance, like there was a new game, like Silent Hill F, which is like more Eastern version of horror, and there is really major differences. So if we interviewed like some more like Eastern players, we might get some different results. Yeah. Yeah, we're like Western, yeah.
Yeah, more questions? If no, I have a questions about, in your paper you just point out that there are more thoughtful and grounded representation on the mental health. I just considering that, how do you think of this shift on the recent trend toward the accurate representation on this mental health in psychology horror?
Yeah, so I've been researching psychological horror for quite a while, and there was like a huge gap between some years. For instance, there is like the Silent Hill revival series. At the time, horror was like more action oriented, and now there's like psychological horror again on the rise. And I think after like COVID era, I think like pandemic like showed us like how hard it can be to live with mental illnesses. So horror games can be like one of the ways to show this, but just one way to do it. Thank you.
Yeah, thank you. Okay, and let's move to the next presentation. And the next presentation is if we play co-designing VR games to study audio-visual integration in children with ADHD. Let's welcome the presenter. Chao Peng, yeah.
All right, thank you. All right, okay, thank you for the introduction. So glad to be here. We are from Rochester, New York. We are a team of game developer, neuroscientists, and pediatricians. And our students cannot be here because of travel concern, but one of our co-author, Roshan, is here, joining us. And we actually together designed VR games for children with ADHD. So ADHD children face difficulty to distinguish sound and speech in noisy environment. So this can be impact their conversation, social interaction, and academic performance. So clinical researchers have used EEG to capture brain signals and understand difficulties through the lens. It's called audio-visual integration. So this AV integration is actually a process that needs individuals to combine what they see with what they hear to create a coherent perception. As we can see in the brain activity map, ADHD have result in weaker and less focused brain responses. The neurotypical children, that in the simulation we did in the VR, so which is focused on target speakers in the VR. However, this clinical understanding doesn't really always translate, this effective intervention. So it's not really effectively translate to the intervention. Here we kind of illustrate the intervention process in the clinical side. So typically, an individual needs to attend to a visual target, and which is surrounded by visual and audio distractors. While they are attending to the target, they wait for the sound associated to the target to be played. And then they need to react to the target when hearing the sound. So this is intervention process need to be repeated with new targets and sounds. So we believe games can help to create effective intervention. This intervention process actually, as you can see, shows similarities with gameplay process. So as they both follow rules about what a user should do, require time limits, and also involve repeated action cycles. So also, if you think about from clinical perspective, in-game metrics can provide continuous behavior insights, which complement traditional assessment like conducted in the clinics or lab settings. So we are aware of some kind of success in the existing games that designed for the children with ADHD, but based on our understanding, they don't really focus on the AV integration or support doctor diagnosis. So in this work, to design the game, we started with understanding the demands from different stakeholders. So for example, for children, a game need to be accessible, playful, and rewarding, but this may have the risk to underspecify clinical mechanism. And for doctors, the outcome needs to be aligned with therapeutic goals, but this can be short of engagement and motivation to the children. So as game designers, basically they need to balance this engagement requirement and also the clinical requirement. So this challenge has led us to define two research questions. The first, how can we conduct a co-design process to inform the game design? So that aligns with therapeutic goals and also support children engagement. And also from there, what are the key design factors we can identify, and how do those factors really influence user experience and performance? So to answer those questions, we had conducted a three-phase design. In the first phase, the designers and doctors had meetings to determine game themes and play mechanics that we think it should be appropriate for children and also meet the clinical objectives. And also, after that, we could develop a VR game prototype that both designer and clinical expertise they already really agreed on. And then in the second phase, the doctor had a home visit to test the game with the children and also their parents. So the feedback the doctor really received from the children and the parents really related to the usability experience. And also we collect some suggestions from the children and the parents about the interaction they would like to have. So based on those feedback and the suggestion, a game designer is refine the game, and then we have another version of the game. In the third phase, all stakeholders really came to the lab. We finalized parameter setting to determine the difficulty levels, worked on the EEG integration, and ensured the in-game tracking and recording system are working properly. So this is more like a technical refinement process. And then the doctor will be assess the data to make sure the data collected is really scientifically valid. And then we could have a finalized version that's really ready for the experiment. Yeah, so I'm done a lot talking, but this is the image showing what the game looks like. As you can see, this is like a fantasy world that the player need to save animals that are trapped in the bubbles. So they need to attend to a target bubble with correct animal in it. So basically, they need matching the animal with the text showing on the screen. And then in pop the bubble when they're hearing the sound. Let me play the video. There are no audio played. Yeah, actually, there should be audio associated to that. It's not playing through, but you can see there's a lot of bubbles. They need grab the shape and drop it when they hear this sound. It's a pretty noisy environment. Actually, we control the difficulty level by controlling the population of the bubbles in the environment, the moving speed, and also the time giving the player to react to the bubble. This is showing 3 difficulty levels. As you can see, the density of the bubble, the moving speed, the slower they move, the more time given to the player, that will make the level less challenging. Based on the feedback from the children and the parents, we implement 3 interaction modalities. So the first one is a click mode, so provides a minimum effort baseline. This is actually the simplest one to use. And the middle one is called the pump mode, which introduces this kind of sustained action repeat. So the player need to press the button 3 times in order to inflate the bubble. The third one is called the drag mode. So introduce this spatial placement that the player will drag the bubble and drop it to the farmland. It offers a sense of control, and then this is require more motions when they are taking the actions. So we conducted an experiment with 5 neurotypical children and 6 children with ADHD. Their age are 7 to 12. Each of them played 9 sessions combined from 3 interaction modality and 3 difficulty levels. We collected data such as questionnaires, in-game performance metrics, EEG responses, and also eye tracking data. Among all kinds of analysis we did, one of the interesting things we did is basically consider correct and incorrect actions. Children make mistakes when this difficulty level is increased. So over the time, also we formed this kind of weighted performance metric, which is validated by the doctors. As shown in the figure on the right, both neurotypical and ADHD group had their performance decreased as the task difficulty level increased. This is sort of like expected. On the left side, across all 3 interaction modalities, neurotypical participants showed relatively stable performance, but ADHD group displayed their highest performance in the click mode and the lowest in the drag. So we noticed that ADHD participants engage more like upper body movements. They like moving the hands and fingers more than the neurotypical students they would do. So this kind of suggests that increased motor is associated with a greater decrease in accuracy for the ADHD children. We have more analysis. Please refer to our paper for the detail. And another thing we found some kind of interesting things in the data over the gameplay time is this alignment. As you can see, the A, B, C labeled, which is showing that the bubble target appearance, EEG signals, and eye gaze event, they all line up in time. So this is kind of important evidence that indicate a potential use of eye gaze as a reasonable biological measure. So in conclusion, we have this kind of 3 takeaways. So low effort interaction in the game can be used as a practical baseline. Tunable parameters can be used as a difficulty leveler. Based on different kids' conditions, we can tune the parameter in order to fit their needs. And also, more importantly, we can use eye tracking as a proxy for the future take-home intervention. So that will allow them to, take the intervention at home rather than go to the clinic office and make appointment. So this could be more convenient for the parents and more convenient for the children. All right, so that concludes my talk. Thank you for your attention. And I would love to thank my collaborators and also, the sponsors for my university, RIT, and also the collaborator from U of R Medical Center. Thank you.
Yes, thanks for the presentation. And sorry to mention before, in fact, this paper got an honorable mention award.
All right, thank you very much.
Now if you have questions, you can, just raise your hand. Okay. If no, I have questions. I thought it's very interesting that you mentioned that the drag modality seems is to be most challenging one, right? And I was wondering that is because of the extreme motor control demand, or you think is from this continuous movement itself?
You know the model from the continuous movement of the bubble?
Yes.
Itself? Okay. I think it's this model requirement. As you can see, they have to drag in the bubble and drop it to the land. So there's spatial movement and holding the bubble, I think, creates this the model requirement. But this is doctor saying when it's in the easy mode, this is effective still for the clinical purpose. When it's getting hard, it will be a little bit hard to control for the children. But from the children perspective, they love this compared to the other two. As you can see, they really think about how the ownership, how the bubble, and how the animal really landed on the land. But I think this is another thing to indicate how we want to balance the clinical side and also children engagement side.
Okay, yeah, thank you. And yeah, there.
Thank you very much, very interesting. I might have missed it, maybe you talked about it. Why are you using VR? So is the immersion, is it like make it easier for ADHD children to focus? Or is the fact that you've got different controllers, is it better for motor function? And the second question, many VR companies, they've got an age limit of 10 or even 12. What's your recommendation about using VR for children with ADHD? For what age limit do you think it's appropriate?
Yeah, okay, thank you for the question. This is also some things we discussed in the phase 1 with the designer and doctors. So one of the things I think from clinical side, doctor allowed to have the VR because it's a multi-sensor tracking. So we want to have the eye gaze information, we want to have the motor information, or we want to have the game information, or game information from the computer, right? But you want to align all this multimodal data together. VR is very convenient. It's very portable, and they can have the potential to use at home. It's not necessarily to love to use this kind of immersive features in the VR, but instead we love this multimodal tracking features in the VR. And also, in our design, we are not really think about too much about the leveraging the VR feature. We more think about the leveraging what the children want to do. So the click and pointing is more intuitive for the children to interact with. So we didn't do the study, but some kind of things like press the button, use the keyboard, maybe not as intuitive as using the VR buttons pointing. And also from the game design perspective, I think there could be further things we can explore what the VR 360 degree of viewing environment could be benefit to them, but this is not included in this paper yet.
Sorry, what was the age limit? At what age do you use it for children?
This is a 7 to 12, which is based on the recommendation from the doctor. I think that could be most effective for the intervention take effects. Yeah, right. Thank you.
Yeah, thank you. And now let's move to another presentation. And let's welcome Nasi Wang to give us a presentation. Who Moved My Heart Brush, Realms of the Heart, a human-AI collaborative gamified Jungian treatment application for depressed teens based on painting therapy. Yeah, please just wait a moment. Okay.
Okay, thank you for. Hello everyone. My name is Nas, and I come from the Shanghai Jiaotong University, and I'm very honored to take part in this, and I'm glad to introduce my self-work about this. And this is the Realms of Hearts, a human AI co-creation art therapy for the teens with depression. Yes, and it's 5 parts. The first is about the research background. The depression is a mental disorder, and often with the loss of interest and pleasure affect individual's work, study, and social functioning. And the adolescence is a high-risk period for the depression. And it has a risk of suicide among the adolescents, and also negatively impacts their cognitive, social, and academic development. And according to World Health Organization survey, the depression affects about 118 million people worldwide, and the number of people with depression increased by more than 25% during the COVID-19 period. And the report on the development of national mental health in China shows that 14% of teens in China are at a varying degree of risks of depression, with the risk being higher among the teens than adults. And I want to introduce the art therapy. The art therapy is a process that uses the art creation to promote self-awareness, self-expression, and self-growth, thereby enhance the well-being. And it applications scenarios is a different conditions such as anxiety disorders, depression, and so on, and the different populations, and about the children, adolescents, and the patients. Yes, and for the digital painting theory, the advantages of digital painting theory is that for the remote online communication, it can expand the scope of treatment, reaching new user groups. And application of digital media, it is virtual reality such as this. And the use of the digital technology art therapy classes has become a trend, especially since the COVID-19 period. The demand for the remote digital art therapy has increased. And the second is a research review. And for the current state of research for the human AI co-creation, is that for the empathy and for the optimization and for the creativity, it has 4 parts of human and AI co-creation parts. And this is a human AI co-creation model. It's about the perception, thinking, exploration, co-creation, build, and test. It's a circle model, and there's 3 levels of artificial intelligence of participating in human AI co-creation as 3 levels. And for the high level, that human and AI do the most of the work for the human. And for the human AI collaborating paintings, there are 2 forms. First, the user and AI take turns drawing, and this is the AI sketching product for the real time, and AI and the humans take turns for the drawing. And the second form is that AI takes the user's drawing as input, process it, and output a generated image. And the limitations is that first, the basic drawing tools like the art therapy aids, and the second is that the potential of AI in digital painting therapy has not been fully explored. And the third is that lack of person experience and gamified elements. And the fourth is that the patient's population for digital painting theory was not segmented. And so we have 3 creativities. The first is that the human-computer collaborative paintings and innovation for the outdoor scenes. And the second is that we developed the human-machine collaboration for art therapy products for the teenagers with depression. And third is that the user segmentation to the teenagers and those suffering from the depression. And third, for the method, we first do the pilot study experiment and to explore the challenges affecting the creative performance in the digital art therapy among the adolescents with mild depression, and to establish the design goals for our future products based on this research. And we recruit 19 teenagers with mild depression and from the age 12 to age 17. Yes, and we first invite them to participate in the art therapy activity, and we provide the children with art supplies and ask them to draw the house tree person. And art therapy communicate with each patient, and each patient draw about at least 30 minutes. After the activity, we conduct the semi-structured interviews. And we get the design goals for the depression children, and they need the pain and points is that the first, most patients they lack access to the art therapy, and so we design the first of our design goal is to use the digital art therapy, a web-based apps, enhance accessibility and make it convenient for the patient to use. And second is that most patients, they has low self-doubt and it has a low self-esteem and the self-doubt. The patients feel that they can't draw and they are bad at drawing and lack confidence and they doubt their own abilities to draw. So we use the AI collaborative art to help the children to get the better experience in the art therapy. The third is that the excessive self-isolation and withdrawal, and most patients, they fear to face the pressures of the outdoor side world, and they don't want to go outside. So we use the based on the behavioral activation theory, it activates the patient behavior and encourages them to leave their homes and engage in the outdoor activities. And the fourth is that for the low engagement and lack of patience, and we use the gamified elements to expand the painting process and art therapy to goes beyond simply draw. It includes more about game and fanning. For the research plan, we do the product design that considers cognitive behavior theory and nature-based intervention theory, and the products to randomize the controlled trials to verify the effectiveness of the product. For the prototypes, and we develop the realms of heart, and these apps based on the behavior activation theory and nature-based intervention theory, and this breaks down the limitations of art therapy, combining the outdoor exploration with the indoor paintings, and it allows teenagers to collect the AI brushes while exploring outdoors, and then use these AI brushes for the human-computer co-creation art therapy. And it includes the two AI-driven strategies. First, we use the Unify mode to transform the nature objects collected by the teenagers into the AI brushes. And then we use the Control Night model to generate the sketches of the corresponding nature objects. And this is the interface of the realms of heart and the brush icons. And it is a storyboard about the realms of heart. We can see that the first is that in the game world, the realms of the heart is disappointed and very the shadows over the realms of heart, and then the users there use their take photographs in the nature, and they can transform the photographs of nature to the brush, and then they can use this brush to draw on the hard canvas to make the realms of heart alive again. And for the interface, this is the take pictures and the brush locks interface, and then it's the drawing interface. There are 3 stages. First, collecting brushes, then creating drawing, and finally reflection. We can see that the users take trees pictures, and the realms of heart can lock the train brush. And for the second, the users use the train brush, and the realms of heart generate a train picture. And then the users discuss with art therapy about this whole period. And this front-end development, the camera code, and so on. And for the backend implication, and we use from the ADE 20K dataset, the top 20 object classes sorted by their total pixel percentage and selected to construct a dataset, especially for the outdoor landscape. Imagine the segmentation. And then we use the yellow model to train to locate and correctly classify the outdoor landscape objects in the images. And for the LDM models, using the pre-trained LDM with a color pitch sketch as input often fails to achieve the precise control over the output image. For example, the brown areas might be used to generate the mountains or castles. This is because the basic models were not specially trained for the segmentic maps. So to address the problem of the precise control, we use the control net to add a trainable branch to the backbone of the LDM network. And by this, we learned to control the image through the color block maps. And this is the participants' drawing cases, and this is the comparison with the existing digital painting series software. And this is the realms of heart. The quality of the generation is okay, and this is control net significantly outperforms the current state of the art game model in the image quality as measured by the following metrics. And for the next part is about the randomized control trio, and this is our inclusion and exclusion criteria, and based on the criteria, we recruit the 13 teenagers aged 20 to 17. And for the questionnaire, we set the first indicators, the depression level, and the secondary indicators, the anxiety level and the well-being. We use the children depression scales, and for the anxiety and well-being, we use GAD7 and the WHO5, the questionnaire. And for the process, the experiment uses a laptop computer equipped with the realms of heart, and it lasts for 4 weeks, 3 times a week for the 40 to 50 minutes each time. And the experiment group, they received art therapy accompanied by a professional art therapy. And for the experiment, we can find that the results show that compared with the conventional treatment alone, the combination of the realms of heart and the conventional treatment had a significant effect on the decreasing of the depression. Yes, and this is the experimental group, and this is control group. And although after the 4 weeks trial, the vast majority of patients still has the CDS scores above the 90s, and the 90 is the cutoff for the depression. But after that, we find that after this, everybody's scores they has increased. This is very great, and we look forward to conducting the long-term trials in the future work. And the anxiety levels, we used the t-test, and the results show that there was more effective in reducing the anxiety levels in patients. And for the well-beings, although there was no statistically significant difference, the means of both groups were higher than the baseline. And for the interview analysis, and from the teens' perspectives, And for the escape, they get rid of the low esteem and the stigma. And they found that previous therapy made me feel like a patient. But when I'm in the state of the mindfulness, I feel like a creator and get rid of anxiety and stress. And for the second part, they get connect with oneself, and the realms of heart makes me less afraid of not drawing well, and I can focus more on feeling myself, and then the connect with nature and others. And first, the patient say that I'm like a leaf in the forest I paint, and then they said at first I was afraid to talk with the art therapist, but she kept encouraging me and was always smiling and very kind. Oh yes, and for the art therapy is a self-acceptance, and the process allows the children to realize and that discovering and accepting themselves is a way to get out of the depression and find harmony in their inner world. And the second is balancing AI support with creative and they replace the patient's hands-on participant. And the third is balancing the uncertainty and the sense of control. And the realms of heart decrease the excessive pursuit of control by people with depression. Yes, and the second is the nature game strategies empowers stress relief, and it combines outdoor nature and exploration with art therapy. And finally, they think it's decrease the barriers in the traditional art therapy. And this is my introduction, and now I'm in the University of Tokyo, and I'm a PhD from the Kozi Yatanis IS Lab, and this is my email. My research interest is human AI co-work and chatbot, and thank you very much. Yes.
Yes, thanks for the presentation, and for the time control, we have to move to another one. And if you have questions, you can discuss after the session. Yeah, thank you. Okay, and then let's welcome our last presenter, Qi and Michael, to give us their presentation. Designing for long-term emotion regulation, a bracing biofeedback game for women in compulsory isolation drug rehabilitation centers. And also this paper got a Best Paper Award. That's congratulations to them. Okay.
Thank you. Hello, everyone. Thanks for joining our presentation. I'm Qi from Tsinghua University. Today, Michael and I will be sharing how we designed it and evaluated. And evaluated a bracing biofeedback game for long-term emotional regulation dedicated to women in compulsory isolation drug rehabilitation centers.
So we know that a significant problem faced by populations with substance dependence is emotion regulation, and the inability to cope with fluctuating emotions can easily lead to relapse. And current interventions like psychotherapy or meditation training are effective, but are also high in cost and can be difficult to learn. So what other options are out there? Well, breathing-based biofeedback games have shown promising results for emotion regulation, but most research has been done under laboratory settings, and whether they're effective for women in drug recovery is unknown. And this is because of the unique challenges faced by women in drug recovery. So what's different for this population? Well, women in recovery face combined effects of social, emotional, and cognitive factors, damages in lung and cognitive function, and live in an isolated environment, which make learning and using emotion regulation skills much harder. And so we decided to design a breathing biofeedback game to support emotion regulation for women in recovery, and we did this by answering two research questions. Through a formative study, we answered our first research question: how do we design the game so it is specific to the needs of this population? And then we evaluated our game through a user study answering our second research question: was this game effective in supporting the transfer of emotion regulation skills into daily life, reducing negative emotions, and generating design implications?
We conducted our formative studies through semi-structured interview with 30 female residents in drug rehabilitation center in China and 4 experts in addiction rehabilitation. Results were analyzed through thematic analysis. What did we find? In terms of their emotional challenges, we found that emotion dysregulation easily leads to relapse, and sustained use produces more negative emotion, forming a vicious cycle. Stigma and cultural gender expectation cause shame and low self-esteem, further worsening emotional management. And finally, cognitive impairment from drug use also make them lose focus, lack motivation, or easily frustrated when learning emotion regulation skills. The woman reported that in the past, breathing practice, uniform pace, and verbal instruction were hard to follow. Limited feedback make them unsure of their progress, and only fixed breathing rhythm were practiced, which do not cater to individual needs. We also found that long-term support, accessibility, and positive identity building were key elements we had to include. From our formative study, we proposed 3 design strategies. First, it must support skill acquisition and transfer, which is done through multiple techniques: repetition, gradual progression, and low-burden interaction. Second, the game also needs to strengthen self-efficacy and self-acceptance, which is designed through narrative feedback elements. Finally, the game must keep users engaged, and we did this by designing an immersive experience, setting appropriate challenges, and visualizing their game progress.
So our game is played across 7 days, and on each day, participants would complete 3 stages. The first stage is always an exercise to establish breathing awareness. During the second stage, participants will learn specialized breathing techniques. And at the third stage, participants practice deep breathing, where they can also select different difficulties according to their own abilities. The first 3 days of the game are all fixed exercises, whereas the later 4 days, participants could choose whatever technique they wanted to practice, giving them complete freedom over the game. And so for stage 2, we want to add something visual to reflect the player's growth. So what's something that grows that everybody knows? A tree. So we used this growing tree as metaphorical feedback for the player's progress, and we made sure it was aesthetically pleasing so players feel positive emotions when seeing it. And to go even crazier, what if in the third stage of the game, you could also rescue mythical beasts and defeat evil spirits just by your breathing? And that's what we did, as we believe this gives an altruistic meaning as well as fosters a sense of responsibility for the breathing task. So we developed the system as a cross-platform Unity game. It captures breathing signals using standard microphones and visualizes key breathing metrics. Breathing is detected through real-time audio processing, and each session begins with an individualized calibration to generate personalized thresholds. Now, we implemented this game in our user study with a total of 60 women from Rehabilitation Center, randomly assigned to 2 groups. The user study lasted 6 weeks in total, the first week being the intervention week and 5 weeks of follow-up. During this period, both groups received standard care of the rehabilitation center, but during the intervention week, participants in Group A played an extra 3 to 15 minutes of the biofeedback game every day. We measured changes in anxiety and depression levels for both groups from baseline to follow-up, and specifically for Group A, we measured their change in breathing ability and engagement to the game, and conducted interviews after each session on how they felt about the gameplay. After the intervention week, Group A participants continued to fill out daily or weekly questionnaires on their breathing technique usage in everyday life.
Quantitatively, we saw improvement in breathing ability and transfer of breathing techniques to daily life among Group A participants. We also showed a flexible use of multiple breathing techniques after learning. In terms of their emotion, both groups experienced a decrease in anxiety and depression levels. However, there was a significant interaction effect suggesting that the rate of decrease in anxiety and depression was significantly greater in the intervention group than in the control group. In terms of their engagement, participants took shorter and shorter time to complete the daily breathing task throughout the week, showing a quick improvement in skill. 76% of participants also choose to continue playing the game at least once after completing the daily task, with 20% of participants continue playing voluntarily every day, which shows strong motivation to play the game. The quantitative result also showed that our design strategy had been successfully implemented. First, for skill acquisition and transfer, participants mentioned that the step-by-step training approach reduced difficulty and immediate feedback increased their confidence. Secondly, self-efficacy was successfully strengthened as participants reported that seeing the tree grow made them aware of their own progress, and the rescue narrative gave them a sense of purpose and built resilience. Finally, users stage engaged because the freedom choose to difficulty felt challenging but not discouraging, motivating them through failure and retry. Some participants also continue to play the game because they enjoy the aesthetic, finding the environment and character appealing.
And so from these results, we derived 5 design implications for future research. Our interviews after the user study showed that most participants explored different breathing techniques because they looked for novelty, challenge, or enjoyed the visual aesthetics. And this suggested that they were more driven by hedonic motivation than utilitarian motivation. And what does this mean? Well, it means that having fun was more preferred than skill building for them. And this may be why a gamified training approach engaged participants better than traditional classroom exercises, since an enjoyable experience fit better with their motivation. Thus, the first design implication is that digital interventions need to prioritize alignment with user motivation to keep them effective and engaging. Secondly, a highly structured digital intervention with lots of prompts can make tasks easier to complete, but can also cause digital dependence. Instead of designing a system for users to use constantly, shouldn't the system help users apply the skills on their own? Thus, we found that in a phase design, users will gradually gain more freedom with how they complete tasks, encouraging them to apply these skills on their own, which is essential for transfer to real life and reducing dependency. Also, did you know that people in highly structured, isolated, and information-limited environments like this often have unique cognitive and emotional experiences? For example, the female participants in our study particularly enjoyed natural imagery as it was a symbol for spatial freedom. They were also more excited towards technology. And finally, collective living also meant that they face unavoidable social conflicts, which suggests that designs must consider ways to resolve social issues too in the future. And these insights could be helpful for future designs in other closed environments. Fourthly, we found that marginalized groups often possess unique potential, and designers need to identify and leverage these traits to create design opportunities. In our study, whilst these women often suppress their emotions, they showed heightened sensitivity and stronger narrative empathy with our game. Many participants empathize deeply with the metaphorical elements in our game, which show that vulnerabilities can also be leveraged as strengths to become empowering designs. And finally, we advocate for design justice for marginalized populations and emotional health. Design justice emphasizes that interactive systems should not only be defined by the default user, but should focus on the real needs of marginalized populations. From our study, we propose the following insights. We must bridge the resource gap with accessible digital tools, create non-judgmental, destigmatized self-regulation spaces, and recognize the commonalities across constrained environments.
Thank you very much for listening. We would be very happy to take your question and hear your feedback. We also welcome further conversation and possible cooperation with the research in related field. On this slide, I have included the iOS beta version of the game. The version you see here is not the same version as the one used in this study, but an extension of it. Together with the paper link and my contact information, please feel free to get in touch if you are interested. Thank you.
Yeah. Thanks for the presentation, and now we do have a quick question. Yeah.
Hi, thanks for the presentation. I'm quite interested in these types of rehab centers you work with, so could you tell us maybe something about the challenges you encountered working with these types of participants?
Thank you very much for the question. Yes, we did face many challenges when we were trying to get in contact with these rehabilitation centers. So we had to go offline to get in like face-to-face contact with them. And because with these centers, there are many, we have to, it's not as simple as we can go in and we can conduct our study. We have to go through many levels of communication and like compromising with their staff and with how these women in recovery live in these centers. So we actually faced many challenges, and we also got rejected a lot in the beginning by many different centers. And finally, we were able to find a center that was quite on board with what we were trying to do in our research. And so after many rounds of discussion again, we were able to come with an agreement to how we conduct this study. So, and if you would like to know any further like details of how this discussion worked, we'd be happy to communicate after this session.
Yeah. One more question?
Yeah. Thank you for your presentation. So my question is, were there any female drug addicts to become who emotionally agitated during the experimental? And how do you prevent the potential risks? Thank you.
Again, great question. So, we conducted our study within the mental health center of the rehabilitation center, and we also had like counseling and psychological experts, mental health experts on call ready if anything did happen. Fortunately, nothing did happen. No female resident, no woman in recovery did get very emotionally agitated, but we did prepare for the situation like that. As well as in our like interview design and our user design, we made sure that like the stimulus of the game or the content we were discussing would not ask them to reveal too much emotionally.
Thank you for the great presentation. I was wondering if having the participants to complete the standard brief training helped them to play the game.
The standard breathing training. So are you referring to the control group we mentioned? Yes. So what was interesting is so our control group isn't actually a group that conducted the standard breathing training. It was part of the standard care program of the entire rehabilitation center. And the standard care program only included a little bit of the training of breathing practices. So it wasn't a very standard like control where like we compared our game versus a traditional breathing, but that's why for both groups, they both received standard care, and we measured the incremental effects of our game for the Group A participants. So it's hard to say whether the breathing practice only a little bit in the standard care program helped them with the game, but I think that's an interesting like a topic we can explore in the future.
Okay, and I think this is all the presentation in these sessions, and yeah, thanks for the presenters, and thanks for joining this presentation. Thanks for our lovely student volunteer. Yes, thank you. And I think, yeah, this presentation is over. And now, have a good lunch and enjoy the rest of the Kai. Yeah, thank you.